Admit them and I will begin the session. Yeah, so good evening, everyone, and welcome to the session two. We are celebrating National Mathematics Week, and under the umbrella of GTF and AIEF, I thanks Mr. Matthew who has given me this wonderful opportunity and platform so that I can interact and share my whatever I have learned with the other educators. So the theme for today's session is recreational mathematics, fun and fundamentals. So let's begin. Here is my brief introduction. Most of you might be knowing and aware about it, but those who are joining the session for day one, my name is Amit and I'm a PhD Maths working in CRPS school for past 22 years. I'm a CVSC BIA Master Trainer, AIEF Master Trainer, Google Certified Trainer, and a few more certifications. Many of you must have uh, got such certifications past 2-3 years as well. So you would like to visit my website and would like to subscribe to my YouTube channel. In between the session, I will share these links with you. Those who haven't visited the websites, you will find a lot of resources, especially for 10th, 11th, and 12th. And even for 6, 7, 8, there are a few resources. You can always visit that. So when we talk about recreational mathematics, so what exactly is the recreational maths means? It's a mathematics carried out for the entertainment purpose rather than a strictly researched, the application, the proving of the formulas. Nothing formal things are considered as a part of the recreational mathematics. So, for example, it may involve the puzzles, games, non-routine maths ideas, problems which are really meant for the fun, enjoyment only. That's for the children, the untrained adult, inspiring their future study of the subject. So as the educator was talking about, the students are not taking interest in mathematics, maybe in grade 9th and 10th, maybe in grade 6th. You discuss such ideas, and of course, the sky is the limit. I share maybe say 4 or 5 ideas with you in today's 1 hour session. But if you get to know about these ideas, you will explore this more. And we have the options. The internet is there. We have the Google is there. So a lot of ideas related to the recreational mathematics you can always find out. We'll begin with a simple problem, which is a startup problem. Please check this out. The reunion of two friends in a park sounded like this. The first one said, "How many kids do you have?" Second, "I have 3 kids." First said, "Wow, how old are they?" The second said, "Well, if you multiply their age, you would get 36. But if you add them up, you will get the number of chairs in the park." The first one counted the number of chairs and said, "You didn't tell me the enough to figure out their ages." The second one then replied, "My oldest kid plays piano very well. Find the ages of the 3 kids." So I think the problem is on your screen. Please read, go through the same. And maths, which is required to be used here, is taught in grades 4. Yes, in grade 4. And please remember, I am not here to test your knowledge. If you get the correct answer, if you do not get the correct answer, it hardly matters. We should enjoy the mathematics, right? So that journey is very, very important, not only the end product as of now. So take your time. I'm giving you 2 minutes to think, ponder upon this problem. And if you have any answer, you can share in the chat box. I'll check out in my second device. So anyone, any idea? How should we begin with the problem? Okay, I have got one response, 2, 3, and 6. Okay. So probably this could be one of the possible answer, right? Is there any other possibility? Check this out. So how to crack this problem? How to start the thinking process? Let's okay, 1, 3, and 12. Okay, that could be another possibility. 5, 6, 5, 3, 3, 9. Oh wow, that's great. I'm getting few responses now. 2 to 9. Okay, that's great. Okay, so since there are three kids, let's consider and call their ages as. Okay, I'm getting the answer 3, 3, 4 also. Let's see. So let's say ages ABC. Right. Now, what do we want? The problem state. The main conditions are at bottom. Please check that out. If you multiply their ages, you would get 36. But if you add them up, you would get the number of chairs in the park. So, if you consider possibilities, so 36. So 1 year old, 1 year old, 36-year old. So it may seems not to be a practical, but biologically the solution may be correct. Mathematically, at least it is correct. And let us have another column of their ages because we need to talk about the age also. So it's coming out to be 38. What are other possibilities? Let's jot down, list them out. So few of the responses I have already seen in the chat box. So 1 to 18 is another possibility. 1, 3, 12 is another possibility. 166 and so on. So basically, since the product of the ages was 36, so we just required to factorize number 36 as a product of three different natural numbers. So is there any other possibility? I have mentioned 8 cases. Is there any possible case which is skipped out? Check this out. So you will check that all the possibilities are already covered, which are available on your screen. Now, we talk about the sum. So I have calculated the sum for your reference in the last column. What's the correct answer? Anyone now? Again in the chat box. If you want to change your answer, if you already answered and you want to change your answer. Yes. The confusion arises when if you add them up, you had get the number of chairs in the park. So number of chairs in the park is this. Even it can be 38 or 21 or 16. But still the second person couldn't figure it out. So my oldest kid plays piano very well. That is the another condition being mentioned over here. So doubt will arise in what all cases? Can anyone let me know? Doubt will be there when the number of chairs were counted as 13. Let's say number of chairs counted were 38. There was no confusion. The answer could have been 1136. The number of chairs counted were 21. Of course, in that case, we have the clear answer as 1, 2, and 18. But now the confusion arises if the number of chairs were counted and they were 13 in number. What is the answer? Is it the option 4 or option 6? Think again. My oldest kid plays piano very well. So the
Option
term oldest.
option six, oldest means it cannot be two, right? Only one will be the oldest.
Yes. So now here comes the role of the English language and understanding the comprehension part. So the oldest as a word is only defined in case of 2 and 9. So that's the final and the correct answer. So can you derive another new problem like the same? Maybe say the product of the ages is 24 and some story like this. So story can be built and you can always have fun with your kids. Oh, story reminded me a mathematical story with a moral. We are a math teacher, right? So we love our subjects, but at the same time, students love to hear stories. So let's begin with one story. Some of you may have heard about this. A father left 17 camels as an estate for his sons. When the father passed away, his sons opened the will. The will of the father stated the eldest son should get half of the 17 camels. Middle son should be given one third of the 17 camels. Youngest son should be given one eighth of the 17 camels. Yes, so as it is mentioned in the story,
Can you give me your phone for a minute? I just need to take this call. I'm on a meeting on the other end. I'm on a meeting in the other.
yes, there were some network issues. Can you excuse me? Let me. Is my screen is visible? Can someone confirm it? No. Oh, so I need to
No,
share
sir.
it once
No, sir.
again. Is it visible now?
Yes, sir.
The educators are still joining. So, okay. Yeah. So, check out the problem once again. A father left 17 camels as an asset for his three sons. When the father passed away, his son opened up the will. The will of the father stated the eldest son should get half of the 17 camels. Middle son should get the one third of the 17 camels. The youngest son should be given one ninth of the 17 camels. So how this can be done? You cannot divide 17 into half or one third or one ninth. So definitely there could have been a fight. So I need to read the chat if I have the answer, some answer here. So is it possible? You can always unmute yourself if you have the solution to this problem.
Yes, sir. 962. 962.
9, 6, and 2. Okay, how did you start it?
Yeah, I have taken x be the half of x, one third of x, one ninth of x. Then I arrived at 18. Then with
So
that I
half
have
of
done
7. Can you please
Sir, we will
repeat?
take the common multiple of 2, 3, and 9.
that is the 18.
Okay.
So with that we have done 18.
Okay, yes. So the basic idea is the wise man, what he did, he bought one camel of his own. So earlier there were 17 camels. Now he added his own camel. So that's a wiser decision. 18 camels are there. Now, out of 18 camels, half of 18 is simply 9. 9 camels are given to the eldest son. One third of 18, that is 6, given to the middle son. And the last swallow, 1/9, that is 2. So he gave 2 camels to the youngest son. So 962 is the answer. Perfectly said. Thank you very much. So when you add these three, it's 17. And he added his own camel. So definitely he will take his camel back and the problem is solved. So if there is a problem, so the moral of the story, if there is a problem, there's a solution. We need to think wisely. Is the attitude of negotiation and problem solving is to find that 18th camel. That is a common ground. And you may have your own perceptions about the moral of this story. So I leave that to you. So basic maths is involved, basic understanding, the fun is involved, and at the end, there is a solution. Okay. Uh, Let us now begin with the another very, very interesting idea of counting the number of squares and rectangles. Please check this out. So how many squares are in this arrangement? And how many rectangles are in this arrangement? Can anyone answer for the first figure? How many squares in this first figure?
One.
One
One.
and one.
One. Both are one.
Yeah. And what about this second figure?
4.
The 5 squares.
5.
Okay,
Yes,
squares
sir.
5 and rectangles.
4, sir. 9, sir.
4.
9.
5.
9.
4.
Rectangles are 9 actually. How? We know every square is a rectangle. So 1, 2, 3, 4, and this was the fifth one. So 5 squares were already counted. Now, other than these 5 squares, let us consider the rectangles. And for that, this is one rectangle, 2 by 1. This is another rectangle, 2 by 1. And similarly, vertically also, we could see 2 more such rectangles. So 5 squares with 4 rectangles, which are not square. So total, it amounts to 9. So squares were clearly 5 and rectangles were 9. Let me extend this idea and consider this grid wherein we have, say, this is n by n, 3 by 3 grid. I have 3 rows and 3 columns here, and we assume every is to be a 1 by 1 square. So now can you please tell me the number of squares and rectangles?
10 squares.
How many squares?
Sir, 10.
10. Okay, I am waiting.
14 squares.
14.
Someone is saying 14.
14 square.
Okay.
14. 14. 9 plus 1 plus 4.
Yeah, it's 14 actually, number of squares if you count. So when we say number of squares, it's referring to the squares of any possible sizes. So 1 by 1, 2 by 2 size, and 3 by 3 size. How many rectangles in this figure?
10.
So 26 rectangles.
Okay, I will not declare the correct answer, but if you are saying 26, let me mention it and let's wait for the others to count.
26, sir.
Okay.
Sir, 32.
Yes, sir, 26. 26.
Okay, someone is saying 32. Let's see. I'm still waiting. Please count.
Sir,
Check this out.
27.
Okay, 27. Let's see.
So 32 squares.
Okay,
33,
32.
sir.
Oh, someone is now close to the correct answer, getting closer and closer.
33, sir.
Chalo, still I'm waiting for the correct
36,
answer.
sir.
Okay. So let's do one thing. चलिए एक चीज करते हैं. 14 squares तो fix हो चुके थे. 14 squares. Let's consider the only rectangles in this figure. So this is 2 by 1 वाला ले लिया. 1, 2, 3, 4.
36 are there, 36.
Yes. 5, 6. 6 are horizontal 2 by 1. 1, 2, 3, 4, 5, 6. Then this is 7th. Then 8, 9. Then 10, 11, 12. After these 12, let me clear the screen and use some another pen. So 12
So
हो चुके थे.
39.
Okay, let's
39
see.
squares.
Okay, 12 हो चुके थे ना. 12. तो 13, 14, 15, and then this 16, 17, and this 18. And after this 18, let me again clear the screen and see. 18 के बाद this 3 by 2 वाला रह गया था. 19, 20, and vertically also 21 and 22. So 14 squares we already calculated, and 22 rectangles which are not square, which amounts to 36, which is the correct answer. So you give such problem to your kids, let them try as you were trying, but the problem arises when I give this problem. Now the situation is more challenging. So whatever answers we were getting, say for 4 by 4 arrangement, can you please mute yourself, everyone? So for say 4 by 4 arrangement, you can see 4 by 4, 3 by 3, 2 by 2, 1 by 1. All such squares are to be counted. So let me list them out in one table. So number of squares were 1 here. Number of rectangles in first figure is 1. In second figure, we counted the number of squares as 5. Please mute yourself. And number of rectangles were 9. In the third figure, we calculated number of squares as 14 and number of rectangles as 36. Let us now observe these numbers carefully. So let's observe the pattern which is being generated, say in the case of number of squares. Can I write? And since the time is limited, I am providing you with the solution part. You should give your students a time to think about this problem. And while you are, say, teaching squares, cubes ka concept in grade 8th, you can always talk about it as a mathematical activity also. So can I say this is 1 square? How 5 can be written? Can I say this is 1 square
Plus 2
plus 2
squares.
square? What's this? 1
1
square
square plus 2 square plus 3 squares.
plus 3 square.
Yes,
That
sir.
means for n cross n, it's nothing but 1 square plus 2 square plus
Up to
3
n square.
square up to n square. And those who are teaching in grade 11th, they know sequence and series.
Yes,
This
sir.
has got the direct formula n plus 1,
1 by 2.
2n plus 1 by 6. And in case of maybe say rectangles, can anyone give me the idea? For number of squares, I have given you the hint.
Sir, 1 cube plus 2 cube plus 3 cube and so on.
Great. Thank you. 1 cube, 9 is 1 cube plus 2 cube, 36. Check कर लीजिए. 1 cube plus 2 cube plus 3 cube. And here we had this figure is 3 by 3. This figure is 2 by 2. This figure is 1 by 1 only. That means Finally, it would be 1
Up to
cube
n cube.
plus 2 cube up to n cube. And again, this is our direct formula. N
And n
square.
plus 1.
n
N into
into
n
n
plus
plus
1.
And
1
n plus 1
divided by
onto
n
whole
square.
square.
Yeah, that's great. So if I ask, so this is the table which already being discussed with you. The formulas for number of squares in that n cross n array is now clear to us. But let me now extend this idea. Oh, what is this in between? Question for rupees 1 crore. So do you have any answer?
Sir, all are correct.
All are correct. Okay. While I teach in my classroom, I had lot of collections of such memes, and suddenly while I am teaching calculus, and you know the integral calculus, differential calculus, students are, I mean, like, oh ye kya ho gaya, my God, so tough topic. In between of my presentation, because I am fortunate that even today in my school, I am using the smart board, digital whiteboard. So I write on that only, right? So in my presentation, such type of slides come up at any moment. So students, I mean, even if they are struggling, they started laughing. And it's my job to bring them back in the classroom, but that's a fun idea. So if you had a collection of certain memes, and if it is possible, you can always use them. So still the correct answer is no one knows. So 1 crore saved. Anyway, how many squares are in this arrangement? And when I say how many squares means how many squares of any possible size. Now I have extended the problem. The basic idea is now being extended. Please think about this. What would happen? चलो मैं आपको एक hint दे रहा हूं. What would happen if this square was there? If this was there. So this would have been your 4 by 4 grid.
4 by 4. Hanji.
And in 4 by 4 grid, remember the number of squares. Total formula is n
1 cube plus 2 cube plus
into
3 cube
no
plus 4 cube.
Yeah.
One
Huh.
square.
One square. One square.
1 square
1
plus 2
square plus 2 square plus 3 square plus 4 square.
squares.
So what's this answer? Check this out.
30.
That is 30. 30.
30, sir.
Now can you give me the answer to the original problem?
29, sir.
Sorry, 20? 9.
29.
Okay. Think
29.
again. Think again.
So 23. 28.
Okay.
Sir, 26.
Oh,
26.
I have 29,
No,
26.
it's 26, sir.
28.
26, sir.
26. Think about this. What will happen?
26, sir. 26.
Yeah, because of this square, what is going to happen if I start removing? Because of this square is removed, then this 2 by 2 square is removed,
3 by 3
then
and 4 by
this
4.
3 by 3 one square is removed, and this finally 4 by 4 square is being removed. So out of those 30 all
4.
squares, I just need to remove those extra squares which I counted. So the correct answer is 26. So try developing the similar problems for yourself. This is one of the possible case. Okay. How many squares of all possible sizes on a chessboard? Yes.
1 square plus 2 square plus up to 8 squares.
Okay, great. See, the idea is very simple, but don't you think so? Most of the students are providing the answer as
136.
64. 8 rows, 8 columns.
64.
So they are going to count all these 1, 2, 3, 4, 5, 6, 7, 8. 8 rows mein hai, 8 columns mein hai. So they generally, and when even as a educator I get to know about this problem, initially my answer and response was number of squares हम बोलते ही रहे हैं on a chessboard 64, but that's not the correct answer. When you simplify this using the direct formula, calculate कर लेना, it's 204. I request everyone to be on mute, or else I will have to remove few of you. I'm sorry for that, but please be on mute.
102.
Sir, 204.
204.
204. Please check your calculation. It's 204. N into n plus 1 into 2n plus 1. 2n plus 1 means 17.
17 divided by 6.
And by 6. So that will give me the answer as 204. Okay. Next, I'm going to talk about another very, very interesting problem referred to as a staircase problem. Check this out. Normal stairs की बात हो रही है. And the problem reads like this. Suppose a child can climb the stairs by taking a 1 step at a time or 2 steps at a time. Normally it happens when we have to climb the stairs, we take usually 1 step, and if we are in hurry, we take 2 steps even. But that we are taking in any possible order. Sometimes I can take 1 step or 2 steps, then mixing of that 1 1 1, then 2 1 1, 2 2 2, 3 2 1, not 3. Only 1 step is allowed and 2 steps are allowed. So he climbs the stairs in different ways each time. The question is, in how many different ways he can climb a 10 steps staircase? So please read the problem once again and try to understand. So one of the possible answer could be 10 stairs, hai na? He take 1,
10.
2 to power 10. Okay. Maybe or may not be. I will not disclose the correct answer as of now. Anyway, so one of the possible answer could be 1 1 1 1 1 1 1 1 1 1, or maybe say 2 2 2 2 2 1 to 5 times, or it could be say 2 2 2 1 1 1 1, or it could be 1 1 followed by 4 times 2, and so on. So if we start writing all those possible cases, we may miss out some cases, we may repeat few cases. So
can we do by combination?
Sorry, can we do it by
Combination.
permutation?
Factorial 10.
Okay.
Factorial. Factorial.
82
10 factorial. Okay. Or someone is saying
10 factorial divided by 2 factorial into 1 factorial.
okay, 1024 55. I am getting few of the answers. 10C1 plus 10C2. Okay. Okay. Please write in the chat box. मैं देख लूंगा, थोड़ा noisy है ना, फिर disturbance हो रहा है. Okay. So none of them is the correct answer. Okay, let's understand this using the method of induction process, mathematical induction. So initially what we will do, instead of say 10 stairs, let's say there is only 1 stair. So for 1 stair, there is only 1 way. 1 step is taken and that's the answer. In case if there were 2 stairs, how many possible ways are there for 2 stairs? How many methods?
2 ways, sir.
1 step, or
two
directly 2 steps are taken. So in this case, we have 2 ways. What if there are 3 stairs? For 3 stairs,
Six
Three,
ways,
one,
sir.
Sir,
Six.
2 ways.
1, 1, 2, 2.
6 ways.
Five.
check this out. There are only 3 possible ways. 1, 1, 1,
1, 1, 1, 1, 2, 2, 1. That's all.
1, 2, and 2, 1. Basically, we are having 1 and 2 with me only, and I need to add them up to get the answer as 3. So there are 3 ways. So those who are thinking in terms of say factorial, say 3 factorial, yeah, 2 key power, something like that, check this out. Real situation is given. No other 4th way is possible. So for 1 stair, 1 way, 2 stairs, 2 ways, that we already have seen. 3 stairs, 3 ways. How many ways for the 4 stairs?
Sir, 4 ways
Only
only.
4 ways, sir. 4
4
ways.
ways.
It seems to be 4 ways because we are trying to generalize that pattern of the numbers 1, 2, 3. So naturally, it will come to our mind that the answer should be 4. Check this out. There are total of
Sir, there are
5
5 ways actually.
5 different ways. Real counting से check कर लीजिए. This is 1, 1, 1, 1. First case 1, 1, 1, 1 step each. Next में क्या करा? 1, 2, 1. Next is 2, 1, 1, 1, 1, 2,
2, 1.
and then 2, 2.
I missed the 2, 2, sir.
Okay. Yeah, it happens. So the basic idea is now the total number of cases are 5. What if there are 5 stairs? So we are going to, consider all those numbers 1 and 2 only and think about this.
Sir, 8.
Oh, great. So what's the answer for the original problem?
Sir,
If you
Fibonacci series.
Fibonacci series, sir.
Fibonacci series.
Great. Thank you very much. So you have got the correct answer. It is related to famous Fibonacci sequence only. See what exactly happened. I used to, whenever I'm going for some arrangements, though in school I teach only grade 11th and 12th, but whenever I get an opportunity to have the arrangement in grades say 6, 7th or 8th, I really love to take those arrangements because those kids are more excited. I really take them to the stairs near their classroom and I perform these type of games and activities with them. So they really perform. They have the simple answer. Looking at this 1 case, 2 case, 3, next would be 4. But actually it is 5. So now they find out all these cases. Generally, they will not be able to generalize it so easily. You know about the Fibonacci sequence. So when you are teaching in class 11, say particularly about Fibonacci sequence series, you can always consider this as a activity. I will be relating the same problem for those who are in class 11, the teaching 11th and 12th, relating it with the permutation also. Wait for 2 minutes. So in this case, if we write down all those cases, it is coming out to be 8. So we have a sequence of numbers 1, 2, 3, 5, 8, and so on. So instead of now writing down these cases, our focus will shift on the sequence which is being generated. So what is the next number here?
13.
Sir,
That
13.
would be 13. Next is 21.
21.
Next would be
34.
30. 34.
55, 89. 89.
Next 55.
55,
And last one will be
89,
89 for next stairs.
144, and so on. What is the answer to the original problem?
89.
You got it correct. The correct answer is yes. Thank you. Now I'm just checking out the, yeah, I'm audible. I think everyone is answering. I'm able to listen. Yeah, 89 for the 10 stairs. Yeah, a lot of you have already given the answers. Thank you. Okay, so staircase problem using permutations. Those who are teaching grade 11th and 12th, understand this basic idea of what is going to happen. Let's count the number of possibilities. when only ones are taken. 1, 1, 1, 1, 10 times, only one case is possible. So this one case is possible. Next, when I take 2, 2, 2, 2, 2, this is only one case which is possible. Main, we need to understand this case. Let's say I have taken 2, and along with 2, I need to take 8 once. So there are total of 9 places which can be filled in 9 factorial ways, out of which one is repeating 8 times. So we just need to divide that by 8 factorial using a simple formula. Everyone must be aware of that. So this gives rise to these 9 cases. What are other possibilities? I take 2 twos, 3 twos, and 4 twos. Remaining will be ones only. And try to rearrange and count the total number of cases, 89. So take this as a challenge, try to understand and get the answer not only by generalizing the sequence and coming and talking about Fibonacci, consider that permutation idea. But here comes the real challenge. ये तो बहुत easy था. The staircase problem extended. What if, and in fact, I never thought about this problem that taking one step at a time or 2 step at a time, ये तो original problem थी हमारी. And now, if even 3 steps are allowed, because when I was taking this activity with grades, I think that was grade 8th, 7th or 8th. So there were 2 students who were very excited and they every time, sir हम तो 3 सीढ़ियां भी चढ़ सकते हैं, वो jump करके दिखा रहे थे मुझे. तो every time I told them, beta, I am telling you only 1 step or 2 steps are to be taken. Sir, 3 क्यों नहीं ले सकते? I can always take that. So then this idea came to my mind, why I am restricting the thought process of a child. What will happen? Coming to this problem, what will happen if taking 3 steps is also allowed? Can anyone make the guesswork, or shall I leave this as a problem for you to think about this?
So for 10 steps only.
Yeah, 10 steps only. If 1 step, 2 step, or 3 steps are allowed. I am giving you the only hint. It is related to, again, Fibonacci sequence, what I called as extended Fibonacci sequence. So Fibonacci में क्या होता है? Previous 2 numbers are added to get the third number. Extended Fibonacci, how I did define, first 3 numbers.
The 3 number is added.
Added. So that's our, say, extended Fibonacci sequence. So answer of this problem lies here only. So think and relate this problem. So I'm putting up this as a problem and doubt only, not giving you the solution to this. And yes, this can be thought about, using that permutation ka idea also. I did solve this problem and matched my answer using the permutation as well. So that's a wonderful idea. Acha, it reminded me, in class 11th, the students has got Python, my computer science students. I posed this problem in front of them and given this a challenge to write down the program for the same. So if you are teaching the students who are computer savvy or maybe love the Python or C++ programming language, they can always come up with the idea of this problem solution directly. Fibonacci is one thing, and getting the directly, he input the number as 10, the answer displays is 89. So that programming can also be done. Okay, so here is our next problem from geometry. Maximum number of regions. Please check this out. I know I'm not giving you a breathing space because in my diary, I had 3 more things to cover and time is running out. So please deal with that. But definitely you're going to love and enjoy this specific problem as well. In how many maximum number of regions can the interior of a circle can be divided by straight lines joining n points on the circumference of a circle. Sometimes what happens, the language comprehension seems to be challenging, not only for students, for us as a teachers as well. So let's understand this problem by splitting this idea. What exactly is required? How many?
Sir, your screen is not getting shared, sir.
Not shared.
Just now it went, sir.
It is shared.
We are not able to see it.
We
Uh,
can say
I can see it is. Please refresh your screen once again. I think.
Sir, it's
Please
not
confirm.
visible.
Ma'am, it
Not
is visible, sir.
It's not visible, sir.
Sir, I think when we pin the screen, then only we can see now. Earlier we were able to see your screen, but now if we pin the screen, then we can see your screen.
Okay. Let me share it once again.
Hanji.
If there is any problem, so maybe that will sort out for some.
No. Yes.
Somebody sharing the screen. That is
Yeah, this is a technology, so it may happen. So please confirm, is it now visible?
Yes, now it is visible.
Yes, sir.
Thank you.
Yes, sir. It's visible.
Okay, thank you. So a problem reads out, in how many maximum number of regions can the interior of a circle can be divided by the straight line joining n points on the circumference of the circle. So to understand this problem, what I will do, consider if 2 points are taken on the circumference. So how many regions are formed?
2.
Maximum 2 regions can be formed only.
Yes.
Clear-cut observation. What will happen if 3 points are taken? For 3 points.
Should I say?
Check this out.
4.
Yeah. 1, 2. There is a smaller region formed here also. And 4. And we are interested in getting the maximum number of possible regions. So this smaller region need to be considered.
Yes.
So 4 regions are formed by taking 3 points.
3 points.
What will happen if I take 4 points on the circumference of this circle? Anywhere. Maximum how many can be formed? Please try out. Draw this diagram. Try out.
Six
7.
regions.
5, sir. 6 regions.
5, 6. Okay. Shall I show you the solution?
Yes.
Yes, sir.
I think 5 regions, sir.
8.
Check this out on your screen.
8 regions.
8 region.
8 only.
This is the smaller one. 4,
Yeah, 8.
5, 7, and 8.
8 है ना?
So 8 regions are formed while I have chosen 4 points on the circumference.
Yes.
What if 5 points are chosen? Check this
16,
out.
sir. 16.
It's 16 actually. 1, 2, smaller one, 3, 4, 5, 6, 7, this 8, 9, 10, this is 11, 12, 13, 14, or ye 15 and 16. So 16 regions are formed with these 5 points. So what if there are 6 points?
Sir, 32.
Okay, great. So for 6 points,
32, sir.
32. Okay. Chalo. The answer is not correct. Though you were able to generalize this sequence, Because a GP was forming here. 2 in case of 2 points. याद करिए 2 points के लिए we had 2 regions were formed, then 4 regions were formed, then 8, then 16. So it clearly seems to be, the logic says, common generalization says the answer is should be 32. But how hard you try to find out, you will not be able to get more than 31 regions. So the correct answer here is 31 and not 32. So isn't it very interesting problem to understand? So really, students, and give a challenge to your kids to draw this diagram. Let them use the compass on a big page. They draw a big circle, choose any 6 points anywhere. And at the same time, remember, if the points are taken in such a way that maybe say points may be taken, that region may not be visible over here. If I have taken this point over here, so possibly there could be a very, very small region formed, but we have to count that region also. So in that case, 31 actually are formed. Regions are formed in case of 6 points. What if 7 points, 8 points, 9 points?
31.
Because now our generalization formula is failed. If you are interested, you may note down the following formula.
Okay, sir.
And here we are not talking and worried and concerned at all about the proving of these formulas. Even I may not be aware of the correct proof of this formula. But you just give the basic idea, students have their skills, they count the number of regions, and they understand a lot of terms, maximum, regions, circle, circumference, points, and then algebra comes over here. The generalization of the sequence, geometric progression. In one problem, unknowingly, you are talking about 10 different ideas at the same time when students are enjoying doing these things. Okay, consider the following interesting geometric problem. Check this out. I will end the session in next 10 minutes. So feedback form will be shared after 10 minutes. So please stay connected. And this time there will be no problem. I had found some different solution. And yes, those who attended the yesterday's session, I already mentioned in that WhatsApp group as well. I will be sharing another feedback form for the day 1 session. And you will need to fill that form so certificate can be generated later on. For this session, I will be sharing after 10 minutes. So interesting geometry problem. Please check this out. क्या कहा है? Take any triangle. Any triangle का मतलब, please do not prefer always equilateral. Draw any triangle. Please mute yourself, everyone. Okay, so take any triangle and construct equilateral triangles on each side whose sides length are same as that of the length of the side of the original triangle. So I think the idea is clear. क्या करना है? कह रहे हैं इसके ऊपर यहाँ ये इक्विलेटरल ट्राइंगल बना दिया, ये वाला, यहाँ ये इक्विलेटरल ट्राइंगल बना दिया like this, और यहाँ ये इक्विलेटरल ट्राइंगल बना दिया like this. So on any triangle, base triangle was taken.
So you are not audible.
Can someone confirm? Am I audible?
You are
You are
audible.
audible.
Yes, sir.
Audible.
You are audible. You are audible.
Yeah. Thank
Yes,
you.
sir, audible.
Yeah. So now what you do, centers of the equilateral triangles will always form an equilateral triangle. This is the center of this equilateral triangle. This is the center, and this is the center of this equilateral triangle, which will definitely coincide with centroid, circumcenter, orthocenter. They all will be the same क्योंकि ये equilateral triangle है. Now the result says if you join these points, the centers, the red triangle will be always equilateral triangle. That's a very amazing and interesting problem in geometry. And here is the demonstration. Anyone aware of the name of this theorem? Anyone heard about this problem earlier? I'm looking in the chat box. Feedback form will be shared in 5 minutes. Please check this out. Acha, anyone heard of the name of Napoleon Bonaparte? Everyone must have heard. All right. So this problem is dedicated to him. He's the one who did talk about this problem, referred to as the Napoleon theorem. Well, I'll do one thing. I will quickly share the link of at least this. You can check out that later on. And there's a geometrical interpretation, the GeoGebra applet, but I'll skip that. And now I will come to the end where I'll be talking about the mathematical equation of a heart. Maths, it's a love. So you are passionate, loving this subject. So am I. So this is a Desmos. Oh, you can recognize this screen. This is a Desmos. This is the classroom situation. One of our very brilliant mathematics teacher shared this with me that her student actually, when she entered in a classroom, before she entered in a classroom, they on the screen had made this for her. So that's the basic idea of geometry, that algebra, the equations of the heart. How this can be done? One of the example using the polar form is here. Even there are a lot of different equations, parametric, polar form, giving rise to the different shapes of the heart. And they are all mathematical equations only, as you can see. I even tried this on using the Wolfram Alpha. I entered this particular equation, Wolfram converted into this, and drawn this diagram of the heart. So give this as a challenge to your kids. How the only half heart can be drawn. What if I flip the X and Y axis? Only. So these type of problems one need to think. Please mute yourself. Yeah. So lastly, check this out. शशि थरूर ने ये ऑफिशियल ट्वीट किया हुआ है few months, I think 1 month back only. So letter received from Jalal Chaturvedi, math teacher from Dhaka, Bangladesh. I believe that mathematics should be taught beyond numbers. In mathematical modeling in grade 12, we explored that your hairline is a good quartic fit. Fourth degree equation, curve fitting की हम बात करते हैं. So this equation resembles with the curve of Shashi Tharoor. So that's the fun. Of course, we are not, talking about the serious part of mathematics, the fun and the fundamentals in mathematics. And there are the certain highly recommended maths books. In my personal library at my home, I have most of all these books available with me, the hard copy. And I have more than, I think, 250 such books which are non-routine. It's not related to the syllabus-based books. All such type of non-routine books, because I love reading a lot of such books. So I highly recommend reading these books. I will share the links of these books with you, the basic idea, the images, so that you can find these books. Time. Okay, so here we come to the end of this session, wherein I'm going to share the feedback form with you now. Please check this out. I'm pasting that feedback form in the chat box. I'll now stop sharing my screen. So please fill this form.
Sir, kindly send it again.
I am also sharing the link of my website and my YouTube channel. Yeah, thank you. So please do subscribe to my YouTube channel and bookmark my website for a lot of wonderful resources. Please fill in this feedback form. So after filling this feedback form, you will receive your certificate in just 2 minutes for sure. And if some of you can confirm if you have already filled and if you have received your feedback, your certificate. It's not opening. It is opening. Check this out. It is opening. Can anyone confirm? Submitted. Okay, thank you. Submitted.
Not opening in my
Yes,
phone
sir,
also.
we are able to submit.
Yeah, many of educators were able to submit. Okay, that's great. Okay, you have received your submitted, yes, but have you received the participation
Yes, sir, I have
certificate?
received.
Sir,
Okay,
Sir,
in
I
my
have received.
received.
sir, in
Okay,
my system,
fantastic.
it's not opening. No idea.
Uh, please save that link and try out using some different link or some different laptop or mobile. Yesterday certificate के लिए मैं already बता चुका हूँ, वो बाद में होगा. PPT, I'm really sorry, I will not share.
Excuse
I'm
me, sir.
working hard for these PPTs. These work for the past 20 years. So sharing is okay, but I will not be able to share my PPT with you. Yeah,
Excuse
thank
me,
you
sir.
very much. Yeah.
Excuse me, sir. Sir,
Yes, sir.
this
Please.
feedback form has been filled and submitted, and where we can get that participating certificate?
In your Gmail account, sir, only.
Okay, thank you, sir.
Check out your Gmail account. You will receive. You
Thank
must
you,
have
sir. Thank
received,
you.
and if it is not available, you check out the spam folder also. Yeah. Thank you very much. Receive the certificate also. Okay. And then this time, this is without logo because I have purchased that plan.
So for me, it's also not.
Please.
I have selected the
Sir, I'm not able
account
to
that
get
has
the
received
form
the
reaching it.
certificate.
You've got the certificate?
Sir, not.
No, sir.
No,
Please
sir.
check your spam folder. Already I have received 209, 210 responses.
Sir, only the mail has been sent that we have received your feedback,
Yeah.
but the certificate is not assigned.
Certificate after 1 minute. After 1 minute.
Sir, how can I
if you
get the
have
link for the form?
One minute. I'll share that once again. I've already shared. Check this out.
Sir, any idea
Feedback.
to make integration as an interesting for the student? They are very
Very difficult question.
So any idea to make the integrations?
We can always have this session on that. I mean, topic-based sessions as well. Not right now, but okay. Yeah, one thing I forget to mention. I'll share my screen once again.
मेरे पास पेंसिल होती तो मैं कितने सुंदर चित्र बनाता
Can you please mute yourself?
से अपने चित्र बनाता रहता एक दिन जब वह चित्र बना रहा था उसने एक बूढ़ा आदमी मिला उसने कृष्ण को पेंसिल दी और कहा
Nice story, but अभी मैम अभी टाइम नहीं है इस चीज का. Certificate, please check करिए. I'm sure you must have received. आप spam check करिए. After filling the form, you will receive. You must have received. Okay. So I think my screen is visible. So tomorrow session is based on competency-based education in mathematics. So please do join using the same link at 4:50 itself. And let me show you the 274 messages, I mean, certificates have been generated. You can see on my screen. So I'll hide your email ID. So you can see your name over here. If your name is visible over here, definitely you will receive certificate in 1 or 2 minutes as such. So please, you can check this out. All must have received their certificates. So Gaurav ji, you will receive your certificate in just 2 minutes. You may require to check your spam folder as well. Abhishek ji, Kaushal ji, Harshil, Harish, yes. So you all please check out. You will get.
Sir, I have received it. I have received the certificate.
Received. Okay, that's great.
Sir,
Sir, I have not received yet.
Ma'am, please fill the form once again. But otherwise, everyone definitely will receive it. I have tried and tested this already with many educators already. So you will receive. Maybe are you using your personal email ID or school ID?
School ID, sir.
Oh, please use your personal ID. Sometime your school domain has restricted this, that receiving the email from the other educators outside your school domain. Do not use your school ID, even not only this session, wherever you are filling such forms, avoid using your school email ID. Use your
Sir, I
personal
got the
ID.
certificate.
Yeah, thank you. Thank you. That's great.
So can you
Thank
please
you.
share the link to him, ma'am? Because we are
Not
using
received.
school ID.
Okay, I'm sharing that. If you have filled using your school ID, please fill it using your personal ID. And check your spam folder at the same time.
Thank you, Amit sir, for
My,
this wonderful session. It was a wonderful session, sir. I received my certificate. Thank you.
Okay, yeah. Thank you. Thank
Thanks a
you.
lot, sir. Thank you.
Yeah, thank
sir,
you.
actually,
So stay
certificate was in
connected.
spam. It was in
thank you,
spam.
sir.
That
Thank
is
you,
what
sir.
I'm
Thank you,
saying.
sir.
Yeah,
I got
thank
it
you.
in
So it
spam.
will be definitely in your spam if it is not directly available. Please do check your spam. 100% this time, I'm
Sir, I
sure
received my
it is in your
certificate.
spam.
Thank you, sir.
Thank you, sir. This
Yeah.
is the certificate for today.
Okay, that's great.
What
Yeah.
about